So this is the linear parent function, y equals x. Both the domain and range go from negative infinity to infinity.
The linear function has symmetry over the origin because it's an odd equation. It is bounded, or it is not bounded, and it has no asymptotes.
This function does not decrease, but it increases to infinity. It also is continuous at all x, and it has no extremes or limits because it goes on forever without any stopping points.
The equation of a quadratic parent function is y equals x squared. When you put this equation into the calculator and graph it, you get a parabola. The symmetry has respect to the y-axis, making it even. The function is bounded below, and there are no asymptotes.
The function is continuous at all x. The function is increasing from 0 to infinity and is decreasing from negative infinity to 0. The function's extrema is an absolute minimum of 0 at x equals 0.
The limit of this function of y equals x squared as x approaches infinity is infinity. The limit of y equals x squared as x approaches negative infinity is infinity. Because the x values are infinite, the domain is negative infinity and positive infinity. The range is from 0 to infinity because there are no y values less than 0.
This parent function is called the cubic function. The equation is f of x equals x cubed. It has symmetry with respect to the origin, so it is an odd function. It is also unbounded and has no asymptotes.
The function is continuous at all x. It increases as you move x from negative infinity to positive infinity. There's no extrema in the end behavior. The limit is as x approaches infinity equals infinity.
The graphed function clearly goes through -1, -1, the origin, and 1, 1. The domain and range equal all real numbers.
Our equation is the inverse linear function, also known as the rational or irrational function. It is f of x equals 1 over x. The domain of this equation is all x values from negative infinity up to, but not including 0, and all x values greater than 0 to infinity. Like the domain, the range is all y values from negative infinity up to, but not including 0, all y values greater than 0 to infinity.
The symmetry of our function is odd because f of negative x is equal to the opposite of f of x. The function is not bounded. The vertical asymptote of our function is x equals 0. The horizontal asymptote is y equals 0. The discontinuity is non-removable and infinite at x equals 0.
The y value of this function are always decreasing from negative infinity up to, but not including 0, and from 0 to infinity. There are no extrema in our function. The end behavior of the function is as the x values increase towards infinity and alternately decrease towards negative infinity, the y value is near 0, making the limit of our function 0.
Our function is the square root function. The domain of this function is from 0 to infinity, and the range of this function is from 0 to infinity.
The continuity is continuous for all non-negative x values. It has no symmetry, and it is bounded below.
The intervals are increasing from 0 to infinity. The extrema is absolute minimum of 0 at x equals 0. There are no asymptotes. The end behavior is limit of square root of x as x approaches infinity equals infinity. The limit of x, the square root of x as x approaches negative infinity does not exist. So the limit of the square root of x equal as x approaches 0 is 0.
For the exponential function, the parent function is f of x is equal to b to the x power. If b is greater than 1, it represents growth and is increasing. If b is between 0 and 1, it represents decay and is decreasing. The y-intercept is always 1, and another point will be the coordinate 1 and the base of the function.
For the increasing function, there is no symmetry. It is bounded below. There is no vertical asymptote and a horizontal asymptote at y equals 0. There is no discontinuity. It increases from negative infinity to positive infinity if b is greater than 1. The end behavior is 0 as it approaches negative infinity, and infinity as it approaches positive infinity. There is no extrema. The domain is negative infinity and positive infinity. The range is 0, infinity.
For the decreasing function, it is the same as the other graph, except it decreases from negative infinity to positive infinity. Also, the end behavior is positive infinity as x approaches negative infinity, and is 0 as x approaches positive infinity.
The logarithmic function is f of x equals log bx. If you can graph the function, you can see that we have a vertical asymptote at x equals 0. There is no symmetry or boundness to this function. There are no horizontal asymptotes, but there is a vertical asymptote at x equals 0, which means that the function starts out at the vertical asymptote.
The function doesn't have holes, which means the function is continuous, increasing from 0 to infinity. There are no extremas. The domain, or the list of x values, is from 0 to infinity.
The range or list of y values is from negative infinity to infinity. The end behavior, or what's happening to the y values as x values approach negative infinity, and infinity is the limit as x approaches negative infinity does not exist, and the limit as x approaches infinity is infinity.
For the absolute value equation, the parent function is y equals absolute value of x. The domain of this function is negative infinity to infinity. The range of this function starts at 0 and goes to infinity.
The extrema for the y equals absolute value x is an absolute min of 0 at x equals 0. It is increasing from 0 to infinity and decreasing from negative infinity to 0. The continuity is continuous at all x because there are no holes or jumps. The two end behaviors are both infinity because there are no limits.
The symmetry for y equals absolute value x is even. The boundedness is bounded below, and there are no asymptotes.
Our function is called the greatest integer function, also known as the floor function or step function. Its equation is shown as f of x equals the largest integer that is less than or equal to x. And if x equals 2, then y equals 2, not 1, because 2 is the greatest integer less than or equal to 2. So that is why there's a closed circle at 2 and an open one over at 1.
The domain of this function is the set of all real numbers. The range is all integers. There's no symmetry and it's not bounded. The limit of the greatest integer of x as x approaches negative infinity is negative infinity, and the limit of the greatest integer of x as x reaches positive infinity is infinity.
There's no extrema, no asymptotes, jump discontinuity at each integer, and the graph is continuous between integers.
The parent function name is a logistic function. The equation for the logistic function is
1 over 1 plus e to the negative x. The domain of this equation is negative infinity, infinity. The range of this equation is 0, 2.
There is no symmetry and it is bounded above and below. The equation has horizontal asymptotes at y equals 0 and y equals 1. The graph is continuous at all x and increases from negative infinity to positive infinity.
There is no extrema. The end behavior of the logistic function as x approaches infinity equals 1. The end behavior of the logistic function as x approaches negative infinity equals 0. And the y-intercept is 0, 1/2.
The equation of the sine function is y equals sine of x. The domain of this function is from negative infinity to infinity. The range is from negative 1 to positive 1.
The graph is symmetric with respect to the origin, making it an odd function. The graph is bounded above and below. There are no vertical or horizontal asymptotes.
There is an absolute maximum of 1 at pi over 2 plus 2 pi k. There is an absolute minimum of negative 1 at 3 pi over 2 plus 2 pi k. K is the element of all integers. The function is continuous and the limit does not exist.
The function for cosine is f of x equals cosine x. The domain of the function is negative infinity, positive infinity, because the x values can range from positive infinity to negative infinity. The range is negative 1, 1, because the graph oscillates between negative 1 and positive 1.
Cosine has even symmetry because you can fold it over the y-axis. The graph is bounded above and below the y-axis. There are no horizontal and no vertical asymptotes on this graph.
The graph is continuously going, therefore there is no discontinuity. The extrema is an absolute maximum of 1 at 0 plus 2 pi k and a absolute minimum of 1 at pi plus 2 pi k. With end behavior, the limit does not exist because it doesn't stop oscillating.